Here I am going to discuss about inductor operation in parallel circuits. So when we talk about inductors which are connected across a voltage source, we need to consider two type of theories. One of them is aiding theories and the other one is opposing theories, right? So in aiding theories, you will have a voltage source connected across an inductor, but here the current I which is entering into coil 1 and coil 2 will be aiding each other. So there won't be any sort of opposition offered by inductor 2 on inductor 1 or inductor 1 on the inductor 2. So in opposing theory, you will have two opposing forces that is created by inductors whenever the current is flown across the circuit, right? So first let us talk about the aiding theories. Okay, so here let us draw a simplified circuit of a voltage source V. Here I have connected voltage source across two conductors, namely L1, L2. Okay, I am representing current by two dots. Okay, so here whenever we see any sort of design circuits having two dots on a incoming conducting circuits, or in other words, whenever current I is flown in a circuit, I1 and I2 will be flown in two different branches, right? Here I1 and I2 both are on the same dots, right? So there will be no opposing forces, there will be aiding properties of inductor. Okay, so as we all know, we need to follow dot rule in this case, right? So here if you clearly see the circuit, the total current I will get divided into I1 and I2. Now you need to note that currents enter into dots of this coil, right? So you need to mention the rule 1 of dot conventions which has to be used. So we need to find self and mutually induced EMF for each end coil, and we need to add both of them. Okay, so if we see the circuit, what will be the voltage induced in the coil 1? Coil 1 means L1 inductor, right? So let us find the voltage induced in coil 1. Okay, so here EMF E1 will be j omega L1 and current is flowing which is I1 plus j omega Mi2. Okay, so let us name this as equation 1, and a similar way EMF induced in coil 2 will be j omega L2 I2 plus j omega L1, sorry, here we don't have L, we have M I1, that is mutually induced EMF in coil 2. Okay, so here we know that E1 is equal to E2 since this is a parallel connection. So the voltage applied across two conductors or two inductors in this case will be similar, right? So equating these two equations, equation 1 and 2, will get is V is equal to j omega L1 I1 plus j omega Mi2 is equal to j omega L2 I2 plus j omega Mi1. Okay, so this is our equation number 3. Let us not get confused over here, it is I1, right? So here we know, since this is a parallel circuit, I will be divided into two branches, that is one branch will be having I1, another branch will be I2. Therefore if we want to know the current I2, it will be equal to I minus I1, right? we need to use this expression, okay, into our above equation number 3. So we'll get is j omega L1 I1 plus j omega m. Since we have value of I2 now, so let us substitute this value I minus I1, which will be equal to j omega L2. Again we need to substitute value of I2 over here. It will be I minus I1 plus j omega m I1. Okay, so let us take j omega I1 as a common. So we will get is j omega L1 I1 under bracket L1 plus L2 minus 2m, which will be equal to j omega I in the bracket L2 minus m. Okay, again if I shift this complete term j omega and this expression over here, I will get is I1 is equal to j omega, j omega will cancel out each other, right? It will be j omega upon j omega, okay, and under bracket will be L2 minus m, and this whole expression needs to be in under this L2 minus m, L1 plus L2 minus 2m, right? So j omega will be cancelling out each other. I will be left with value of I1. I1 will be L2 minus m upon L1 plus L2 minus 2m into I, right? So this is what we get for I1. Now in a similar way, if we take I1 as a expression, I2 minus I1, since to save time, let us not waste by deriving this equation again. You just need to put value of I1 over here instead of I2, and you will be left out with I2. So directly I am writing over here I2 is equal to L1 minus m upon L1 plus L2 minus 2m multiplied by I. Okay, so we got two expressions which is for I1 and I2. Please note guys, this is for aiding circuits, okay. For opposing circuits, value of I1 and I2 will be different, okay. So now we need to substitute value of I1 and I2 into our equation number 3, that is this one, right? Equation number 3. So we'll get is E1 is equal to V, which is equal to j omega under whole root L2 minus m L1 upon L1 plus L2 minus 2m, and the plus it will be, I think, yes, L1 minus m upon L1 plus L2 minus 2m, and here you are having m, the second term, and this whole term will be multiplied by I, right? So V is equal to j omega I. Now you need to take this L1 terms inside, okay, and you need to equate those two equations. So it is simple addition rule. So you left out with L1 L2 minus m L1 plus, now in the second term you need to multiply m with L1, so it will be m L1 minus m square upon, this complete term is similar, right? So L1 plus L2 minus 2m. So here if we equate again, so you will left out with j omega I L1 L2 minus m square upon L1 plus L2 minus 2m, right? So this is our final equation, that is fifth. This is for E1, right? V is equal to E1 is equal to j omega I and the mentioned term, right? So this equation has to be effective inductance, since we have taken both of inductor in our circuit, and this equation contains effect of I2 and I1. So this is actually V voltage j omega L eq I, right? So this complete expression, expression number 5, it is of L eq, right? This term is of L eq. So L eq means L1 L2 minus m square upon L1 plus L2 minus 2m. So remember guys, whenever we solve problem having two inductors in circuit which has been aiding each other in terms of current, so that the flux that is being generated by L1 will not oppose the flux that is being generated by L2. Okay, so in that case you can use this equation in order to find out the voltage. The same way, if we take a parallel operation with a opposing circuit, you will be having a voltage source. Let us connect this to voltage source across two inductors. Okay, but now there is a catch over here. Here you are having dot over this thing and dot under this inductor number L2. So if you see the current I1 and I2, the current I1 is entering directly into dot, and in the other case the current I2 that is entering into this branch, entering the L2 first, and then it is being passed on to a dot, right? So in this case the I1 and I2 will be opposing in nature, right? So here, in what will happen in this case, the self induced EMF will oppose the mutually induced EMF, right? So what we need to do, again we need to apply a KVL over here. So if we apply a KVL, we will get expression of V is equal to j omega L1 I1 minus j omega m L2, right? So let us name it as equation 1. The same way, if we apply into loop 2, it is j omega L1 L2 I2 minus j omega m I1. This is our equation number 2. So equating those two equations, number 1 and 2, we will left out with j omega L1 I1 minus j omega m L2, which will be equal to j omega L2 I2 minus j omega m I1. Okay, here again we need to find out the loop currents, that is I1 is equal to, again let us simplify first. I is equal to I1 plus I2. I2 will be I minus I1. So we need to substitute value of I2 into above equation. We will get j omega L1 I1 minus j omega m I minus I1, which will be equal to j omega L2 I minus I1 minus j omega m I1. Okay, again we will take j omega I1 as a common, so we will get j omega I1 L1 plus L2 plus 2m which will be equal to j omega I. Again, if we take j omega I as common, we will be lifting out with L2 plus m only. Okay, so again in this expression, if we keep I1 on the left hand side and the rest all other terms on right hand side, so we will get expression of I1 which will be equal to L2 plus m upon L1 plus L2 plus 2m, right? And this whole term will be multiplied by I. Again, in this case, you need to know j omega and j omega will cancel out each other, right? So this is for I1. In the same way, if we substitute expression of I1, which is I1 plus I2, which is equal to I, and if we find out value of I1, which is equal to I2 minus I1, and again substituting this value into this equation, we will get another expression which is of I2. Again, I am not solving this expression in detail because this will be somewhat similar to the above equation. So I2 will be equal to L1 plus m upon L1 plus L2 plus 2m, right? So now we got expression of I1 and I2. Okay, so let us substitute both of this value into above equation, so that we'll get a complete expression which will be V is equal to j omega L1 L2 plus m upon L1 plus L2 plus 2m minus j omega m L1 plus m upon L1 plus L2 plus 2m multiplied by I, right? So if you don't know still, this is I1 and this is I2, right? So let us solve further. Okay, what we'll do here is we'll just substitute those two values, j omega I, and let us take L1 inside. Okay, here I will take L1 inside and I outside, right? So I have taken on the left hand side, and here if you multiply L1 term into this thing, so we'll get is L1 plus L2 plus m L1 minus m L1 minus m square upon L1 plus L2 plus 2m multiplied by I. Okay, so I have done nothing. I have just substituted by multiplying value of L1 into this term, and in the same way I have calculated the complete equations, right? So if you do it by your own, you will also get the same expression over here, right? So again, what we will get is V is equal to j omega L1 L2 minus m square upon, okay, this will cancel out each other, right? So that's why we are lefting out with L1 L2 minus m square upon L1 plus L2 plus 2m, and that has to be multiplied with I, right? So we all know V is equal to j omega Li. Okay, this is expression of voltage induced. Now comparing these two equations, this complete term is Leq, right? So what we are seeing basically here is, we are saying V is equal to j omega L, but this is an equivalent circuit for opposing circuits, right? So we can write this expression as this, and whenever we get a numerical asking to find the L equivalent or voltage induced in the circuit, we need to see whether that circuit is of opposing nature or aiding nature. Suppose, let us take, if that circuit is of opposing nature, then we need to use the expression of L equivalent, which is equal to L1 L2 minus m square upon L1 plus L2 plus 2m. Okay, so that's all for you guys. I hope you like this session. If you have any sort of doubt, you can just reach me out at my official mail ID. Okay, so have a nice day. Goodbye.